All right. So let's start off with ellipses. Any questions on the ellipse videos that you guys have? Cecilia, if you can grab the door, and can you also grab the front light? Any questions from the videos? I forget what the embedded question was. Was it, what are the 5 major points on the ellipse? Okay, so what are the 5 major points on the ellipse? Just, yeah, that's perfect. Is that what it said? What are the 5 points on the major axis? Okay, yeah, same question. Reworded a little differently. Thanks. What are they? 2 foci. And by the way, so that you can pronounce that word foci or foci. I heard another teacher pronouncing it foci, and I'm like, that does not sound right. So I went and looked it up. They're both correct. So just for the record, in case you were wondering. So I have 2 foci. What else? 2 vertices and the center. And what do we call the center? HK. Oh, isn't that exciting? Look, we've got another HK, and it seems like every single shape that we do, and they're not called shapes, they're called conic sections. Every single one that we do has an HK in it, and it happens to be the most important point on that particular conic section. Okay, so yeah, so those are my 5 points on the major axis. Now, you've got your overview out, I would assume. Talk to me about some equations here, the standard equation. So let's get the standard equation for the first ellipse. What is the standard equation for the first guy? Oh, hang on, I need to be reconnected. I learned patience. All right, let's try this again. What'd you say? Okay. And then what was the second equation? What was different about the second equation? The 2 denominators are switched. Everything else is identical, right? Okay, so we've got then x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Okay, so talk to me a little bit about what was on your overview. What is A? Distance between the center and the vertex. Now that's pretty easy when you're sitting there looking at the overview. But folks, on your test, is your test next week or is it the week after? Do you remember? I think it's the 9th. Okay. I don't think that's next week. I think that's the week after. So on your test, you're not going to have the overview. Okay, so that's great. It's easy to right this minute, look at it and go, oh, A is the distance from the center to the vertex. But you need to know that come test time. Okay, so the overview is great during class. Okay, so what's B? From the center to the end of the minor axis. Yeah, we don't have a special term for that. It's just the end of the minor axis. All right, and then what is C? Distance from the center to one of the focus points, or both of the focus points, but to each of the foci. Okay, now this is one thing I did not talk about on my video because my video is watched more than just by SCC students, more than just by my students. There are several teachers at SCC that use my videos, and then I find, because I can look these things up on YouTube, I find that occasionally I'll have people from other parts of the country or other parts of the world. I'm like, you poor souls. Although I feel more sorry for you guys because you have to listen to me twice. At least they only have to listen to me on the video. But anyway, so I don't talk about this on the video. I don't talk about weird stuff on the video. I try to stick to the math itself. But I have these guys' names, okay? So the one that's standing up vertically, that guy I call Larry the Cucumber. Okay, now if you don't know who Larry the Cucumber is, Google it. Okay, and some of you probably are going, right? Okay, so anyway, so that's the one I call him Larry. And then that guy over there, he makes me hungry. I just call him the pickle on a plate. I mean, we might as well go ahead and just stick with the whole cucumber pickle theme, right? So I got Larry the Cucumber who stands up, and then I have the pickle on the plate. I don't talk about those things on the videos because those people who aren't in my classes would think I'm more weird than you guys even think, okay? So, so I just try to keep it pretty normal on the videos. All right, so that's what we'll name them. If you happen to go to the tutoring center or to somebody here for tutoring and you start talking about the pickle, they're probably not gonna know what in the world you're talking about, okay? That's totally a Roberts thing. That is not going to be published in any textbook, all right? Okay, so let's just go ahead and jump into number 2, but before I can look at number 2, I need to look at the directions. So the directions before number 1, first of all, tells me that I need a graph. Okay, now, can you go back in your mind? What were the things that I needed to know to be able to graph a circle? Yeah, HK and R, right? HK and R. So in order to draw an ellipse, what do you think I'm gonna need to know? I gotta know H and K. I gotta know where the center is. And then what else should I need to know? A, I need to know where to put my 2 vertices, and B, I need to know where to put the ends of the minor axis, okay? So I actually need to have 4 things to graph an ellipse, H and K, A and B. All right, so I'm supposed to graph, I'm supposed to give the domain and range, and I'm supposed to find the 2 focus points, and I'm supposed to find the center. Okay, it's a lot of stuff, all right? Now, I'm not doing number 1, but when you compare number 1 to number 2, what do you like better about number 1 that number 2 doesn't? Yeah, I gotta get standard equation, right? So number 2 is not in standard form. I have to get my standard form, okay? Now, when I go back up here, the biggest thing to remember about standard form, you gotta have a 1 on the right side. You gotta have a 1. Okay, and that's really the main issue with number 2. I don't have a 1. Okay, now how am I going to make that 96 into a 1? And please don't tell me that I'm going to subtract 95. Yeah, I'm going to divide every single term by that 96. Okay, so let's just go ahead. We'll divide by 96, we'll divide by 96, and we'll divide by 96. Okay, now if you need your calculators out, I don't have a problem with that. So on the right side, I got my equals 1, that's what I wanted. And on the left side, we need to reduce our fractions. So forget the variables for a minute, and you should probably even be able to do this one without a calculator. Hopefully you know your times tables. But what is the fraction 12 over 96? How does that reduce? 1 over 8, right? Okay, so then just throw your variable back in there, and now I have an x squared over 8. Plus, how does 8 over 96 reduce? That should be pretty easy now. Yeah, 1 over 12, so that's going to be a y squared over 12. Okay. Okay, so my first decision to make, is this a Larry or is this a pickle? Is it a Larry or is it a pickle? Well, okay, before I say yes or no, what am I looking for? What's gonna answer that question? Okay, so something about the denominator. What am I looking for in my denominators? What's that? I want to know which one's bigger. I want to know which one's bigger. All right, look up here. I think I said this in the overview, but I'm gonna repeat it now. Okay. Look at Larry. The vertical one. Look at Larry. Okay. Rewind. You can look at Larry in a minute. Look at your overview. There's a very interesting statement that I've made on your overview about A and B. I haven't pointed it out yet today. What is it? Cecilia, what do you think? Say it again, A is always on the, very good, very good. It's not what I'm looking for, but that's leading me to the right page, so you're absolutely right. A is on the major axis, always. What's another statement that's really important about A and B on that overview? Okay, so we already said that. You're right. You're right. A is always on the major. Oh, B is always on the minor. Okay. I'm losing my mind. Aren't you glad to know that? Add this to your overview. It's not over. That's why you're not getting it. You can actually come to this conclusion, okay? You said that A is always on which axis? The major axis. Why do we call the major axis major? It's always longer, right? So then what do you know about the value of A when you compare it to the value of B? It's always got to be bigger. A is always, always, always going to be larger than B on the ellipse. A is always going to be larger than B on the ellipse. So you can just put A is greater than B for the ellipse. Okay. Now that's going to fall through on hyperbolas. Okay, but for the ellipse, A has to be larger than B. A has to be greater than B. So let's go back to Larry up here. Okay. Which is the larger denominator again? Always? Yeah, the A squared is always going to be larger than B squared for the ellipse. And who is A squared underneath for Larry? The Y's. Okay? So when my larger denominator is under the Y's, I got a Larry. Look at the pickle on the plate. The larger denominator is underneath the X's, so when the larger denominator is underneath the X's, I've got the pickle on a plate. Okay, it's horizontal. All right, so then let's go back to our example. This is going to be an easy question now. Is it a Larry or is it a pickle? It's a Larry. And why is it a Larry? Yeah, because my 12 is my larger denominator and it's underneath my Y's. Okay, so this has to be a Larry. Okay, so talk to me about where's the center, because that's one of the things I had to list. Where's the center? How do you know that? Yeah, I mean, it doesn't say X minus any number up on top or Y minus any number up on top. So I got 0, 0. Okay, so you can put that on your graph because that's what we're trying to do. What were the four things you had to have to be able to graph? HK, A and B. Okay, so I've got my H and my K listed there on paper. What's my A? It's not 12, that's my A squared. Oh, don't use your calculator. Don't use your calculator on this one. I'm going to show you something cool on this one that you don't need to use a calculator on. What's my A? Square root of 12, right? I mean, guys, I'm going to erase this. So if I have A squared as 12, take the square root of both sides, okay? And hopefully maybe your brain is saying, Ms. Roberts, if I take the square root of both sides, isn't it supposed to be plus or minus the square root of 12? Yes, but A is a distance. Distance is not negative, right? So blah, blah, blah. Okay. So then so this is kind of, so Juan pulled out his calculator, which is totally normal because we don't know what the square root of 12 is. But let me show you something that'll tax your brain just slightly, but it's good for your brain to be taxed on occasion. So what's a really pretty square root close to the square root of 12? What's a pretty square, because square root of 12 is not pretty, right? We don't know it. What's one that's pretty? So the square root of 16. So let me come over here on some itchy paper. Okay, so we would like to know what the square root of 12 is. You know that the square root of 16 is equal to what? 4. What's a really pretty square root on the other side of the square root of 12? Square root of 9, which is 3. So then without a calculator, I know automatically when I go graph this that I just need to graph 3 point something, right? I need to put a dot in between 3 and 4. See what I'm saying? So that's an easier way to do that. Could you plug it into the calculator? Yes, you could. Okay, but you don't need to. One more statement. Is the square root of 12 closer to the root 9 or closer to the root 16? Why would you say it's closer to the 9? Because it's only 3 units away instead of 4 units away. Yeah, so this is probably close to 3.4-ish. Okay, and you could check me if you wanted to on that. All right, but now it's really easy to graph. Okay, so let's come over here. Where's my graph? And this is my A value. Should my A value go up and down, or should my A value go right and left? Why is it going to go up and down? Because it's a Larry, okay? And Larry has his major axis up and down. So we're going to go up 3.4-ish units. So here's 3, here's 4, here's 3.4. And we're going to go down the same amount. Okay. In a minute, I don't remember if I need it on this question or not, but I'll do it when I need it. I'll do it when I need it. What's my B value? Square root of 8, right? And so if I use the same concept here, square root of 8 is smaller than the square root of 9. What's another one on the other side of the square root of 8 that's pretty? Square root of 4, right? 4, which is 2. Now, question, is the square root of 8 closer to the 2 or the 3? It's closer to the 3 because there's a lot less distance between 8 and 9. So I would say that this is probably like 2.8 or 2.9. Okay. So then how do I put that on my graph? Which direction? Yeah, it's going to go right and left, 2.9. Now, now that I've drawn my center, H and K, and I've drawn my A's and my B's, connect the dots. Larry's gained a little bit of weight. Okay. So my directions were that I was supposed to find a graph, check. I was supposed to write the center, check. I was supposed to give the domain and the range. Let's do that next. Okay, domain and range. Okay, now where is my domain? What's the leftmost value? Yeah, so here, it's actually, remember that 2.9 was just a guess at a number? It's not completely accurate. So here's actually what I was gonna say next. Square root of 8 is accurate, but it's unsimplified. Square root of 8 is like telling me that you have an answer of 2/4. Would you ever give me an answer of 2/4? I hope not. If your answer came out to 2/4, what would you write down? 1/2. You would reduce your fraction. Square root of 8 is unsimplified. Okay, so hopefully you guys remember how to simplify your roots. Just remember, this is the same thing as square root of 4 times 2, right? 4 times 2 is 8. And the square root of 4 piece is 2. And the square root of 2, I don't know, so it stays inside. Okay, so that's the simplified version of the root. So then use that for your domain. Okay, so what's your domain now? -2 root 2 all the way to 2 root 2. And what kind of symbols do I want on that? I need square brackets because I am using those values. Okay, for range, what do we run into then again with range? Yeah, so I need to simplify that square root of 12. Okay, so you think about the fact that, like, you wouldn't want to use a 6 times 2 because neither of those is a perfect root. What's the better pair for 12? Yeah, 3 times 4. So the square root of the 4 piece is 2, and the square root of 3 is just the square root of 3. Okay, so then what's your range? -2 root 3 to +2 root 3. Okay, so I asked for the center, I asked for the domain, the range, the graph, and then I think the only other thing I asked for were the foci. Is that the last thing? Okay, you're gonna need your overview for this. What letter is assigned to your foci? C, yeah. Don't you have a little mini equation somewhere on your overview? Now I'm starting to second guess myself about that overview. That has a C involved in it. What'd you say, Juan? Little dude. Yeah, absolutely. What is little dude? Good, good, good. So I'm going to come up here and I'm going to add little dude onto my original equations here. So a squared minus b squared equals c squared. I only need little dude when I'm working with foci. Okay, any other time he doesn't get used. All right, so that's the only time I can put him into any practice. So a squared minus b squared. Remember, you already had your a squared and your b squared when you got your standard equation. Okay, so those are already available to you. So you've got your a squared was 12 minus your b squared, which was 8, is equal to your c squared. Okay, so your c squared then is 4, your c is 2. And what is your c value again? Okay, it's the distance from the center to the foci. It's the distance from the center to the foci. So since I asked you for the foci on this, what are we going to say? Where do those foci land? Do I have to go up and down to get them, or do I have to go right and left to get them? Up and down. How far? 2. So where do they land? Yeah, 0, 2, and 0, -2. Now let me tell you, when you've got coordinates like that, I don't have a problem if you write that 0 plus or minus 2. I'm fine with that. You don't have to. If you want to write it 0, 2, and 0, -2, I'm good with that as well. Okay. But mathematicians, what you're going to find out, mathematicians are borderline lazy. That's why we have symbols for everything. We don't want to write it out. Okay, borderline lazy. We're not all the way lazy. Okay, all right, so I think I got everything on that one. Let's look at number 3. This one's a little bit more exciting. I don't have a center at 0, 0. But at least it's in standard form. I don't have to do anything extra to get it in standard form. Okay. Okay, what's your center? -3, 2. What's your A value? Why is it 6? 36 is A squared. Remember, the larger denominator is your A squared. So your A value is 6. What's your B value? 4. Is it a Larry or a pickle? It's another Larry. It's another Larry. Okay. I'm supposed to graph. So let's go ahead, put some numbers on your graph there. So we've got -3, 2. There's a center. Which direction do I go from the center? How far up and down? 6 units up and down. Okay. 2, 4, 6. 2, 4, 6. And what else do I do from the center? Left and right, how far? 4. So 2, 4, 2, 4. Okay, so now you have top, bottom, right, and left. Go ahead and draw your Larry. All right, how about your domain? Anybody? -7. What was the second value? To 1. Okay. Do you guys remember that one of the things that I talked to you about back when we were doing circles? You can count blocks on your ellipse to see that it's from -7 to 1. You can do that. But you can also go, let me pull it down so I can try to reach it. You can also look at just math. So the X value is -3. And the X value got changed right and left by the B value. So if you're at -3 and you go left 4, that's where you get a -7. If you're at -3 and you go right 4, you add 4, that's how you get a 1. Okay, so you can also do that mathematically. It doesn't just have to be by counting blocks. Okay, and then also what is same concept for the range. So what's your range? Okay, so from -4 up to 8. And again, for your range, it's the 2 value that's changing. If you take 2 and drop 6 units, 2 minus 6, that's -4. And if you go up 6 units, 2 plus 6 is 8. So again, you can count blocks if you want to. At the time where counting blocks would be a real pain is if, you know, your A and your B value was something like 45 and 92, right? That could get a little bit tricky. So the math is good to know there. And I think the only other thing that we have to get is our foci. So what are we gonna do to get foci? We need little dude, don't we? Okay, and little dude is gonna be my A squared, 36, minus my B squared, which is 16. So C squared is 20. Now, I never said you had to graph the foci. You just have to give me the foci. You don't need the focus points for graphing, okay? So like, I don't care what the decimal value is here. I just want the accurate value, okay? So what is the square root of 20? 2 root 5. Okay, that's fine. What is C again? It's a distance. Okay, so how am I going to get to my foci? Where do I begin? At the center, okay. And which direction am I going to go from the center to get to my foci, even though I don't have to graph them? Up and down, okay. Now, think about this. If I'm going to go up and if I'm going to go down, what value in my coordinate for the center, what's changing if I'm starting at the center and I move up? What's changing? Is it the X value or is it the Y value that changes? It's the Y value that changes. Ups and downs are the Y values, okay? So here I am at -3, 2. My focus is going to be at -3 something because I'm not moving right and left. Okay, I have to go up to get a focus point. So that -3 is unchanged. It's only my Y value that's changing. Where does my Y value begin? What's my Y value at the center? 2, and I have to go up how far? 2 root 5. Okay, so I literally have to start at 2 and go up 2 root 5. 2 plus 2 root 5. Can you add those two together? Other than with a calculator? Other than with a calculator, can you add those together? Why can you not add those together? They're not like terms. That's as simplified as that's going to get, okay? So since they're not like terms, we're going to leave it alone. Now, that's only one of my focus points. So how do I get to my other focus point? I'm starting at 2 and I'm going down. What symbol do we use in math for going down? Minus, right? So it's going to be a 2 minus 2 root 5. Or if you blink, you're going to miss this. Look up on the screen for a minute. You ready? There it is. If you want to write them separately, that's fine. But you don't have to. Okay. Now, let me say one more thing here before I move on. If my C value, remember on the last question, my C value was pretty. If my C value is pretty, don't you dare write 2 plus or minus 2. They're like terms. You can add and subtract them. Okay, you need to come up with 2 coordinates for that. But if they're not like terms, I don't have a problem with you combining them this way. Okay, you can still write 2 separate ones. You're still not going to give me decimals. Decimals are inaccurate. That's why I don't like them. They're inaccurate. Okay, so I'm still not going to give decimals here. I am, but yeah, this is the best way to write it. Okay, moving on. We'll skip number 4, but I do need the directions, which says to find an equation. Find an equation. Do you remember back on parabolas, I gave you a list of, I think it was like 4 tips. What were those 4 tips I gave you? What? Just throw some out at me. Yeah, sketch what you got. What else? Go back and look. It was in the parabola section, not in the overview. It was in the passive. Say it again. Yeah, figure out what kind of standard equation you needed. So that, in this case, it would be figure out if it's a pickle or a Larry, right? What else did those tips say? What? Say it, Dylan? Concavity, yep. So that would be the pickle or the Larry part. And then there was one more. Yeah, C, H, and K. And then for an ellipse, what's that going to change to? H, K, A, and B. Okay. So, so same concept, same types of tips here that we will use for the ellipse. So let's start out by sketching what we have. Because a lot of times our picture is going to hand us tons of information that we can't get by just reading, okay? So first thing, let's go ahead and we will draw my center, which occurs at 2, 0. Okay. Now, the next piece of information says that the minor axis equals 6. Do I know how to draw that yet? Just by reading that piece? Yeah, I don't know how to draw that yet, so we'll keep on moving. The last piece says that the major axis, oh, here's something important. The major axis is horizontal. Okay? Pickle or Larry? Oh, it's a pickle. Okay? So I know then that from the center, I'm going to go right and I'm going to go left. This is going to be my major axis. Okay. So you've got H and K. That was given to you. What is your A value? So I have one person who spoke up. I hear a 9. Is that your A value? You think it's 18? Okay. Somebody else for a 9? Any others? So we've got 9, we've got 18. So it says that the major axis equals 9. What's wrong one? 3? 7? Okay. We might as well get some other numbers in here. Anybody for an 8? Anybody for 3? Oh, no, we got a 3. Anybody for 2? 4? Let's go back up to our example pictures. So we know it's a pickle, right? Or sorry, yeah, pickle on a plate. What's A again? From the center to the vertex. It would be what? From the center to the vertex is A. How many A's are on that picture? There's 2 of them. How long, according to that picture, how long is the major axis? It's 2A, right? Because I've got an A plus another A. So like if one of my A's is 12, my major axis is 24, right? I'll say that again. If one of my A's is 12, then the whole entire major axis is 24, right? Okay, so let's go back. Where was it? Okay, so here, my major axis is equal to 9. What is my A? 4.5? You're actually correct. It's just ugly. Now, here's the thing. Don't you have to square that A? Right? To get the equation, don't you have to have an A squared? Okay. My method's easier. You want to know it? Yeah? Okay. You know what half of 9 is? 9/2. Hey, what's half of 21? 21/2. What's half of 157? 157/2. Oh, look, you can do that mentally. Fractions. Gain another point. Decimals, still at 0. Because now I'm going to have to square that. Would you rather square 9/2? Can you do that mentally? Or can you mentally square 4.5? I can't. But I can so square 9/2 mentally, right? Yeah, let's go with fractions. They're easier. Okay, so I'm going to say then that my A is 9/2. What's my B? 3. Oh, phew, that was an easy one. Okay, because 2 3s make a 6. Okay, the direction said write an equation, and I need the H, the K, the A, and the B. Got them all, so let's go write them down. Okay, so let's see here. What's going to go on top for the first fraction? X minus 2 quantity squared, right? The X's are always first in ellipses. Okay, what's going to go on top for the second fraction? Okay, y squared. For now, I'll just put y minus 0. I'll clean it up here in a second, but you're right, y squared would have been fine. Don't forget your equals 1 on the other side. Does my A go under the X's or does my A go under the Y's? It goes under the X's. Remember, it was a pickle. We already established that. And it's supposed to be an A squared down there, right? Okay, so for now, I'll just write 9/2 squared. I'll clean it up here in just a minute. This one, I'm just really showing my work along the way. And then my other denominator is going to be 3 squared. Yeah, that's a 9. Okay, let's clean it up. Top of the first fraction, leave it. X minus 2 quantity squared, that's good. Whew. Bottom, what's 9/2 squared? 81/4. I'll come back to that. Plus, cleaned up version for the second term. Y squared over 9. Don't forget your equals 1. Hey guys, this is a good answer. I'm totally fine with this. My lab is also going to accept another answer. Remind me of the rule for dividing fractions. What do you do when you have to divide fractions? Multiply by the reciprocal, okay? And so one of the things that my lab will do, again, this is a good answer. I'm okay with this. This will gain you full credit if I ask you for the equation, okay? This answer is good. But my lab, what it does, it takes it a step further and it inverts and multiplies the 81/4s. And so what it looks like is 4 glob squared over 81. Okay, so it inverts and multiplies. The rest of it is the same. That's a good answer too. I'm fine with either one. It's whatever you're comfortable with. Okay, the rest of it's the same. So just so you know, but if you look up, help me solve this, this is the direction it's going to take. But I've tested it a few times. It does accept the first one as an answer. And if it doesn't, you need to let me know. Okay, because that's something I can fix. But it does accept that first one as an answer on all the ones that I've tested. Okay. All right. So let's take a look at number 6. I've been doing a lot of work. I want you guys to do some work here. Okay. So let's take a look at number 6. What do you think you're going to do first? Sketch it. Yeah. And what are the 4 things that you're really focused on finding to be able to write an equation? H, K, A, and B. Yep. Yep. All right. So what I'm going to do, and by the way, there's something here that you haven't seen yet today, but you did see it when we worked on the parabolas, and you also saw it when we worked on the circles. Okay, so I'm gonna leave the room because a lot of times I'm intimidating when I am here. So I'm gonna leave the room for a few minutes, see what you can come up with here, talk to each other, I'm fine with that. If you're gonna get close to each other though, mask it up, all right? So I'm leaving, I'll be back. I figure out, I don't know, 3-4 minutes. You're finished. Check with somebody around you. See if they got the same thing you got. Isn't that to the right and upward? To the right, to the right. From the origin, right? Okay, where's your x-axis? Oh, okay, this is your x-axis. This is your x-axis. It is. I agree with that one. So, how do you get this today? What is A? Oh, okay. So then, is this from the center to the vertex? No, it's from the center to the. Yeah. So this shouldn't be A. What should it be? And then the other thing is that I know that you just didn't want to count, but like here's 3 and here's 7, so it's my own, right? Okay, so let's take a look. Sorry, Elia. If you still have the question when I get through it, ask it, okay? I did not draw, oh, yeah, can't do that. I'm too loud under there. I did not draw the point that's on my ellipse. I only drew the 2 foci because immediately as soon as I draw my 2 foci, I've been given several pieces of information. Okay, so let's just start with that. What kind of information am I given just by drawing 2 foci? Okay, how do I find the center? Yeah, it's just going to be smack dab in the middle, right? How many units are between the 2 foci? There's 10, right? So in order to get to the center, I just have to go either 5 from the right or from the left. Okay, so then if that's the case, my center is going to be this guy, right? Okay, so let's write that down. Where is my center? 2, -3. Okay, so there's my H and my K, all right? What else does this hand me? What? More information, please. What else does the picture tell me? It's a pickle. Yeah, who was that? Who said that? I could, Savannah, you said that? Okay, so yeah, it's a pickle. Okay, good, good. All right, what else does this hand me? C, what's my C? 5, good. Okay, so my C value is 5. Okay, I think that's about all I can get by just drawing 2 foci. Okay, now what did you do back in, I'm not even gonna draw the other point. What did you do back in parabolas and circles when you were just given a point on the conic section? Yeah, plug it in for what? X and Y. Okay, so this guy, I'm just gonna call it X and Y. And you see, there's a much easier way to do this question. There is, but they're not all gonna be this gorgeous. Okay, I will point that out to you in a minute, but let's go the roundabout way that I need to on this one, possibly for other questions. So let's, all right, I've got fraction plus fraction equals 1. My first fraction says x minus h. So since I'm plugging in an x value here, what am I gonna plug in on top? 2 is my x value minus 2 is my h value, quantity squared. Oh, that's just gonna be 0, right? And what's gonna go underneath this guy? So is it an a squared or is it a b squared? Why is it a squared? It's a pickle. So that means that the larger value, the a squared, has to go under the x's. I'm good with that. All right, so let's put an a squared under there. And then on top of the other one, this is gonna be y minus k. So what will I write? 1 minus negative, so plus 3, squared over b squared, right? Because I don't know what b is yet. Does that make sense, Aaliyah? Okay. Now, the whole entire first fraction goes away because it's 0 over a number. Okay, so 0 divided by anything is just 0. So all I really have to do is clean up the second piece. So this is going to be, let's see, 4 squared. Up on top I have 16 over b squared equals 1. Okay, what do I do to simplify that? You know this, you might have forgotten it. Multiply on both sides by b squared. Multiply on both sides by b squared. So this is gonna say 16 equals b squared. Oh, okay, well, I have enough information out as far as my b's are concerned, because when I'm writing my equation, which is my goal, I need a b squared. I've got it, okay? All right. I'm still missing a piece of information. What are the 4 things I have to write the equation? H, K, A, and B. And what is it that I'm missing? I'm still missing the A value. How am I gonna find that A value? Little dude. Right? Because you now have your B's and your C's. Your B's and your C's can lead you to finding your A's. Okay, so let's use little dude. So we have a squared minus b squared equals c squared. So that'll be a squared minus 16 is equal to c squared 25, right? You guys with me? Okay. Add 16 to both sides. And your a squared is, your a squared is 41. Now, since my equation requires a squared, I'm just going to leave that as a squared equals 41. If I had to graph, then I would have to take the square root of 41. Okay, but it didn't ask me to graph. It only asked me for the equation, so I don't need to do that extra work for the a squared and the b squared. Okay, I'm finally ready to write my equation. Here we go. So I've got fraction plus fraction equals 1. What's going to go on the top of the first fraction? X minus 2 quantity squared. What's going to go on top of the second fraction? Y plus 3 quantity squared. What will go on the bottom of the first fraction? Wait, what? it's just a 41, right? Because it's an a squared. So just a 41. And what's going to go on the bottom of the second fraction? 16. Aaliyah, did you still have the question that you had? Any questions at all? Okay. All right, how many more do I have? Just 2. Okay, I wanted to make sure that I left time for both of these. Okay, so you see number 7, and what does your brain say? Oh boy. Why? It's not in standard form. And what am I going to have to do? How am I going to put it in standard form? I got to complete the square. I got to complete the square. Okay, so do you remember me telling you that circles was the easiest completing the square? Parabolas is a little harder. Ellipses, we're stepping it up a notch. And then hyperbolas are the hardest of all. Okay, so we're on level 3. Okay, we can do this. We've practiced completing the square multiple times now. So let's complete the square. So what is step 1 on completing the square? I really didn't have to deal with this step too much. None at all for circles, and only a little bit for parabolas. And if you don't remember, then get out your how-to on completing the square. You've got it. One more time. Take out. Yep, get rid of your A. Get rid of your A. I have 2 different A's. What's the A's? What's the A for the X's? And by the way, don't get confused about the A being the A in the ellipse formula compared to the A being AX squared plus BX plus C. Okay, so 2 different A's that I'm talking about. Sorry. What's the A for the X's? 9. What's the A for the Y's? 16. So I need to take out both of those A's. So let's start by factoring. So I'm only going to deal with my X's first. We'll take out a 9. If you take a 9 out of those 2 terms, what are the new 2 terms? Minus 4x. Now, before you close your bracket, leave some space to complete the square. And let's go ahead and do the same thing for the Y's. What are you taking out for the Y's? Okay, now I'm going to be a stickler here, okay? And I'm not going to accept that answer. What kind of a 16 are you taking out? A positive 16, and you need to write that sign. And you say, Ms. Roberts, why in the world are you being like picky like that? It's going to matter when we get to hyperbolas. Okay, so I'm taking out a positive 16. What are those 2 terms when I take out the positive 16? And then you want to leave some space for completing the square on the Y's. And on your how-to, what does step number? I'm having a hard time today. What's step number 2 say? Move your constant. Get it over on the other side. Okay, so it's going to be a 44 on the other side. Okay, so then what's next in my how-to? Yeah, now I'm ready for the whole half a B, right? Take half and square. Okay, so let's look at the X's first. What's half of B? -2. Square it. 4. What am I supposed to do with that 4? Add it to both sides. Please, please, please stop. Pay attention. Pay attention. Yes, I'm adding 4 here. But when I add it to both sides, that really wasn't a 4. What is it? It's actually a 36. Okay, so I know it's a 4 on the inside, but really its value is a 36. So when I go to the other side, I'm not adding 4 to both sides. Oh wait, I'm adding a 36 really to both sides. It's just that one of those 4s looked like a 9 times 4. Okay, big deal there. That's a big deal. And I did show that to you on the how-to. Let's go do the same thing for the Y's. Okay, then, well, this one's easy. Okay, so take half. Take half of your b, -2. What am I supposed to do with it? Which is, so I'm gonna add 4 to both sides, right? But it's really not a 4. Yeah, it's actually a 64 because it's a positive 16 times my 4. Okay, this takes some practice. A lot of students leave that out, so be careful. Okay, what's next on my how-to? No, it's not, well, you can combine like terms. That's not what I was gonna say. If I combine like terms, I've got 130, 140, 144. Yeah, say it again, Aaliyah. Yeah, factor the trinomial. Okay, so that's next in the how-to, factor the trinomial. So let's leave the 9 there. I'm not doing anything with that. What is that trinomial factored? X minus 2 quantity squared. And then I've got my plus 16. So go factor your y trinomial. Hey, do you guys, can you see the ellipse standard equation? It's starting to emerge. You see it? Okay, it's not, we're not here yet. What's the last thing I need to do? Divide everything by 144. Because I need that 1 over on the right side. Now, all I really care about is reducing the fraction 9 over 144. So what's 9 over 144 reduced? You can use your calculators. It's 1 over 16. So I got x minus 2 quantity squared over 16 plus, which makes the next piece really easy. What's 16 over 144 reduced? 1 over 9. So this is going to be y minus 2 squared over 9 is equal to 1. Now I can finally start the question. The directions were write an equation. Okay, I got that much. Find the center, find the vertices. Now, I didn't finish, but I'd like to do one more completing the square in the last 8 minutes. I really want to get that completing the square in. So let's go down to number 8. I didn't finish number 7, okay? I didn't finish it. But if I want to get number 8, at least the completing the square part done. This should go a little faster. Okay, what are you going to do for the x pieces? Factor out of 2. So what will that be? Leave some space to complete the square. All right, what are you factoring out of the y's? Good, it's a positive 3. And what's left over? Y squared minus 6y, leave yourself some space to complete the square. And then move the constant, so it's going to be a negative 23. Should I just quit right now and just say, well, that's going to be a negative, so I don't need to worry about it? No, keep on completing the square. Okay, so let's take half and square. Okay, take half of your first b term. 1, square it, 1, and we need to add it to both sides. So I'm gonna add 1 on the left side, it looks like, but actually its value is what? A 2, so let's add 2 on the other side. I really didn't add 1 to both sides. I'm really adding a 2 to both sides. It's just that one of them has a different look to it. For your y's, take half. Negative 3, square it. 9, what do I do? Yeah, so I'm actually adding 27 to both sides. Okay. If I combine my like terms over on the right, What do you get? Should just be 6, right? Because that's the 2 and the 27 is 29. 29 minus 23. What step am I on to get the left side done? Say it again. Factor, good. Yep, factor the trinomial. Okay, so I have 2 times, what's my x trinomial factored? X plus 1. Plus 3 times, what's my y trinomial factored? Y minus 3. And then what's next? Divide everything by 6. First term? Oh, I'm sorry, I'm so boring. Okay, does that make sense? It was a little easier the second time around, wasn't it? Okay, so it's not so bad. It's really not so bad. Okay, I got 4 minutes. Let's go back to number 7. Where is my center? 2, 2. I'm supposed to find the center and the vertices. In which direction am I going to locate my vertices? Up, down, or right, left? How do you know it's going to be right, left? My larger value is under the x's. It's a pickle, right? Now, here's what I like to do. I'm a very visual learner. So over on my itchy paper, I just say, okay, here's the coordinate 2, 2. That's my center. And I'm going to go right, and I'm going to go left. And what's my A value? Because isn't my vertices that's going to be found at the end of my A value, right? So I need to go 4 right and 4 left, so that's going to be plus 4 and minus 4. So in the center, which value is going to change? Is it the x or the y that's going to change? It's my x value that's going to change. So I want to take my x value of 2, and I want to go left 4, but I also want to go right 4. So if you go left 4, where will you get that? Negative 2, 2. And if you go right 4, what are you going to get? 6, 2. Okay. Can we do the same thing for number 8? Center for number 8. Negative 1, positive 3. Okay. What is my A value? Yeah, my A value is the square root of 3. And where will I find my vertices? Right, left, or up, down? Right, left. It's another pickle, isn't it? So I've got my negative 1, 3 coordinate, and I want to go right root 3, and I want to go left root 3. So again, think about the value that's changing. So where are my vertices? Negative 1 plus or minus the square root of 3, comma 3, right? Negative 1 plus or minus root 3, that's just the new x piece for each of the 2 vertices. And then the y piece remained a 3. It didn't change. And you can write those separately if you want. I'm fine with that. Okay? But you don't have to. Wow, that was good timing. Any questions in the last minute? No questions? All right, guys, it's Wednesday, so you have a good weekend. I will see you on Monday, right? Yeah. It's not until the